Technical Symposium from the Siemens team. Great welcome to you as well. Today we'll focus on the cooling in data centers. We'll talk about the perception and the common pain points of our customers. When we talk with them, say, what's your view? What's difficult for you when we talk about cooling? We'll talk about how we can optimize cooling and when we can get a dynamic algorithm to get the cooling infrastructure always at the best performances and what the benefits we'll get of that optimization aspect, which is important as well. Because Siemens is not only focused on cooling and automation, but we have a wide range of solutions. We would like to point out from a design perspective what should be from a consulting company the first requisite when we design new facilities or we think to retrofit existing ones. Then we'll go to the conclusions, and then if we have spare time, then we'll have time for questions and answers. So let's start from the first part. So cooling is difficult to manage in a large facility or even in a small, medium-sized data center. We do see that a cooling unit, air handling unit or a crack unit has a different influences in the surrounding space. We have cooling influence, the blue areas, and heating influences. So, but if we consider different air handling units in the same white space, we do have different results. Each one of them has a different contributor to the white space. So we said, okay, some of them, like the one we are showing at the moment, is negligible contributor, if not zero. The last one seems or looks like it's very, very important. I cannot switch that off without compromising the stability and the performances of my data center cooling infrastructure. Complexity. We have seen a lot of papers and formulas to deal with. We typically see that all the manual works that has been done or is done on a daily basis by the data center operators, we typically tend to oversize the cooling capacity in case of hotspots. Sometimes we say, oh, that rack is too hot, why don't we install a new cooling unit? The effect is, if we bring more air turbulence or airflow dynamics into the white space, we create too much pressure under the raised floor. Excessive airflows brings to hotspots. So this is where a lot of racks are too hot or hotter than others. And the result is, because there is too hot temperature in some racks, I cannot install enough servers or storage systems into the same rack because I'm scared that the risk is too high to deal with that condition. And then I stop. I give up. All of those conditions are primarily taken into account by data center operators when they deal with daily duties. So how can we help to achieve better conditions? What should be the best in the art of the technology? So everything starts with a design process. So typically, to fit with some standards in the market, we need to have redundancy to avoid some risks. those cooling units that are excessive in terms of capacity will bring some inefficiencies in general. Handling or manually optimizing the cooling infrastructure is too difficult to be handled by a team of people. It's either difficult from a human perspective, it's also difficult from a OpEx perspective. We are allocating resources to manually fix and learn how the cooling system is reacting to minimum changes that we implement. Maybe changing some set points of temperature or airflow of the air. The result, in general, we waste energy. What we would like to achieve, and we have several examples in the literature of the data center industry, of some algorithms that are able to bring down the consumption of the cooling units and follow the IT load behavior. The more IT load we consume, then we spend slightly more energy to cool down the servers, not wasting so much energy like in the left-hand side of the graph. How an holistic approach, an algorithm, should look like. The control algorithm should measure how the heat load is distributed across the data center with simple temperature sensors. We do have sensors everywhere in the data center. We have sensors at the room level, at the rack level. We do have it at the server level. If we monitor each one of those servers, we do have a very granular monitoring of the temperature distribution. We can determine how the cooling airflow can influence the data center white space. We can predict, according to the influence map, how that cooling units can be managed better than in the past by controlling the cooling units through an external controller. The system could learn by doing, and having a continuous feedback to the system, then we'll get into a situation where we can optimize and having a fast working point. How solution could look like, we don't want to make too much propaganda of products, but just to illustrate that a very simple solution made by sensors and controllers and the software can really improve by controlling the settings of each and every cooling units in the white space, the economics of the cooling infrastructure. And the solution is valid both for an existing brownfield data centers as well as for a greenfield data centers. Many of you as a consultants are exposed to deal with your customers and consult them what is best to do. Changing the cooling infrastructure or adapting it with new technologies. Software is the best at it. So essentially, we started from a static approach to managing cooling infrastructure to a dynamic one, where all the cooling units are managed differently with different setting points. You see one of them is also switched off because it's not necessary. One is running at 100% of its capacity. What are the benefits we perceived with the customers? One is the risk reduction. When we talk with sensitive customers, risk is one of the factors that they take into account. The reduction of the hotspots, it's equivalent to reduced risk, and we achieved 98% of reduction in an installed client. We say we save cooling energy, so we are managing cooling units and we are switching them off when they are not necessary. We are reducing the speed of fans. We are obliging them to fit with the cooling, with the capacity required by the IT assets. As a result, we get a lower PV. The more we save energy on the variable part of the energy consumption, because we did not, or we cannot influence much the consumption of the IT part. This is what the IT companies do better. We can achieve a better PV, which for a small data center is quite negligible, but for a medium to large size data centers has an impact of tens or hundreds of thousands of euros per year, if not millions. More capacity available. Many of you are now dealing with co-location companies. They are dominating the market. They are offering services cheaper than any enterprise data center can do. But they have different tenants, and with each one of them, they have different SLA, service level agreements. It means that every one of those tenants expect different temperature set points for their inlet temperatures. Why not achieving SLA compliance with the same algorithm to avoid fees in case we exceed the temperature we supply to our customers at any point in time? The result showed in the picture, 80 degrees Fahrenheit is 27 degrees, so it's within the envelope allowed for data centers for 97.5%. So it's quite a huge result in energy efficiency for that. And this is something that the co-location companies are really looking at. So looking at the how can we make that storyline better? Or how can we approach the data center management since day one of operations with a more holistic approach? You certainly remember the architecture of this proposed solution. We try to make it better, making all our OEM partners, which mounts our HVAC controllers, automatically recognized by the software, in order to avoid installation of third-party controllers, which has a cost and an additional risk. The data center is not about cooling only. It's about power, it's about fires, it's about security. All of those disciplines have to be integrated, have to be brought into a single management platform. This is where the most effective result can come and can be achieved. That's why the cooling module should be seen as a part of a wider management platform that is able to bring all those disciplines together and as a single panel class bring all the reports and the notifications and the alarms all in one platform. And then the analytics. Everybody talks about analytics today. It's not something we like to do, but we see the effect and the benefits of bringing the data we collect from the facility and from the IT side into the cloud, or in any platform that is able to elaborate those data at the edge. We'll talk about it later. Just to speed up and giving some hints about what is achievable. The same management platform is able to bring all the data together. We talked about influence maps. If you remember earlier, this is the way the algorithm can work. Thermal maps as well, It's a way to identify any hotspots visually in our platform. But we also know that we have different stakeholders in the company. So the management platform has to provide different dashboards, different KPIs to different people. The same data that the CEO or CTO has to look at are different than the data center manager. So it's really important to differentiate the same data according to the stakeholders. We are providing those data too. Alarms. Better to have one alarm management platform rather than many. We break this IT silos, we bring all the data together, and we can manage them. No alarm will get lost if not acknowledged or solved by any one of the organization. And reports from any type. Having the power to get the data in a single data lake and providing customizable reports according to the company needs, it's quite impressive and really bring value to all the stakeholders. You want to sell this project too. Last, we are going to the closure of the presentation. Is about optimizing services through the cloud. So we said, let's bring the data into the cloud. So not all of the data we collect locally at the edge are important. But some of them are, especially when we talk about multi-site data centers. So how can we compare the effectiveness of one data center with the other? So certainly multi-site governance is something that is primarily of interest for the stakeholders adopting cloud-based applications. Honestly, still today, from many companies, even cloud providers, there is a sort of resiliency, reluctancy to bring their data into the cloud. It's a suspiciousness approach, it's maybe a mindset that will change time by time, but that's certainly something that we, as a vendor, we have to deal with. And you also have to understand the psychological impact of convincing clients to bring data into the cloud. But that, the fact that we can automate analysis based on rules and automatic events that are triggered by the applications, or even having a platform that allows to manage customer services from remote locations. It's quite important to reduce the costs, the operative costs of the company, and tie together vendors and clients. Benefits. We leverage transparency. Once you have all of those data in one single platform, whatever on-premise management platform you have, once you get the data, you can really deal with them as you want. Save energy was one of the key topics, and still will remain when we approach the topic from a cooling perspective, but it's much more. We increase of system uptime or optimize the maintenance through fault detection diagnostics algorithms or predictive maintenance as well. That's what a cloud-based platform could really achieve in short. Getting to the conclusions, what we have talked today. So AI is definitively must to have because it brings the value it promises. We talked about maximizing energy saving, reducing PUE, removing hotspots, increasing IT capacity, or complying with SLAs. But A lot of companies still use different tools to manage different areas of their data center operations. Many of them still, 1 minute I'm done, use Excel files. And you know how it's complex to manage different copies of the same Excel file with versioning not matching one each other. It's really a waste of energy and money. Unique integrated IT architecture can really help to get into a situation where all of those waste is forgotten. And focus on the lifecycle management of the assets. Extending lifetime, optimizing maintenance, reducing OPEX is a must to achieve. Thank you. If you have any question, I'm open to answer.